Starting with the discussion of a pop quiz 11, which is related to bonding, rate, and the moles. So in question 1 part A, potassium is a group 1 element. Name and describe the bonding in potassium. As we know, potassium is a metal. So what kind of bonding is there in the metal? The metal will always have a metallic bond. So whenever there are metals, metals always have the metallic. And then how we explain this metallic bonding? There is a regular arrangement of the positive ion or the lattice of a positive ion, and the free electrons are there, which are held together by a strong electrostatic force. So how you score the remaining 3 marks? You will mention there is a lattice of positive ion. In this case, you can also say potassium ion, and there are free electrons are there, and there's a strong electrostatic attraction between them. So the distribution of the marks for this question, because it's a metal here, so it will have metallic bond, you will score 1 mark. When you mention there's a lattice of positive ions, or you can mention lattice of a potassium ion, you will score the 2nd mark. Then there are free or the delocalized electrons are there, and then the 4th mark is for strong electrostatic attraction between the lattice of positive ion and the delocalized electron between them. Then potassium combined with sulfur and form an ionic compound. So physical properties, what does physical property mean? Physical property refers to melting or a boiling point or electrical conductivity or solubility. So what are the physical properties of ionic compound? Ionic compounds have high melting or boiling point. High melting or a boiling refers to one point only. Like if you mention high melting point, that is fine. You mention high boiling point, that is also correct. But you cannot mention like mention as separately. High melting and a boiling point, that is one, and the second physical quantity you can mention they have high density, or they can conduct electricity in molten and aqueous. So they can conduct electricity in molten or aqueous state, or they are water soluble. You can also mention that. So this is even discussion. They change like potassium combined with chlorine, potassium combined with iodine. They all have the same answer, that they will have the same because of general properties of ionic compounds are similar. Then complete dot and cross diagram to arrangement of atoms and the charges on potassium sulfide. So potassium sulfide, the electronic configuration for potassium atom, it is 2, 8, 8, and 1. And for sulfur belongs to sulfur 16, so it is 2, 8, and 6. So first we have to complete their shells, and then what happened afterward, like potassium is 2, 8, 8, 1. So there is 2, 8, then another 8 is there, and then 1 is there. First, I'm drawing potassium atom, and then I will turn into an ion. The same thing for the second potassium as well. And sulfur is 2, 8, and 16. 2, 8, and 6. Total is 16. 2, 8, and 6. And that is cross. 1, 2, 3, 4, 5, 6. These are atoms. But then what happened? There will be a transfer of electron. So potassium loses electron. So this electron transfer from potassium to this electron transfer potassium to sulfur. This electron also transfer from potassium to sulfur. So what is the charge left on potassium? It loses 1 electron. So +1, +1, and each sulfur gain 2 electron. And if you don't draw this shell, the empty shell, if you don't draw, that is also fine. If you draw and make it empty, the fourth one, that is also correct. So this is a structure, ionic structure of potassium sulfide. Then when potassium is added to a water, it reacts vigorous and colored flame is seen. The equation is shown here. Calculate the volume in centimeter cube for a hydrogen gas that is formed. So calculate the number of moles of potassium. So first part, we always solve by using a formula. And which formula we'll use? Because we have the mass of potassium. So we'll use a formula that moles equal mass in gram divided by the molar mass. So moles equals to 2.34. Sorry, mass in gram is 2.34. And molar mass of a potassium is 39. So we write 13. So it will be 2.34 divided by 39. That is equals to 0.06. The second part we solve by using a ratio. Determine the number of moles of hydrogen. So we already have potassium. We'll take a ratio between potassium and hydrogen. So potassium and hydrogen, according to equation, this 2 is there. So 2 and hydrogen molecule 1. So 2:1 is the ratio. If we have 0.06, then hydrogen will be X. Cross multiply, so X will be 0.06 divided by 2 because we cross multiply. That is 0.03. This will give us the moles of hydrogen. Then again, we'll use a formula because it's like formula, ratio formula. And now we need the volume of a gas. So we have the formula that moles equal volume of the gas in dm cube divided by molar mass. So moles, how many moles are there? We have 0.03. Volume in decimeter cube, 24 is divided, other side will be multiplied. So 0.03 multiplied by 24, that is equals to 0.72. So 0.72 decimeter cube. But that's a volume of gas. But the question is, we need in cm cube, so what we have to do? To convert the decimeter cube into centimeter cube, we multiply by 1000. So it will be 720 centimeter. So first part, we solve by using a formula. The second is by ratio, and the third one is also by formula. So this was a pop quiz related to bonding rate and moles.